Hello everyone. In today's session, we'll discuss a tree data structure a problem, that is lowest common ancestor of a binary tree. Okay, so let's understand what is lowest common ancestor of a binary tree. So if we consider this example, so we have a root where the elements are 3, 5, 1, 6, 2, 0, 8, 7, 4, and so we have two nodes here, 5 and 1. We have to find out a lowest common ancestor between 5 and 1. Okay, so if you consider 5, what is the ancestor of 5 is 3, and what is the ancestor of 2? That is 1. For 1 it's a 3, so the common ancestor between 5 and 1 is 3. Okay, so we have to return 3 is the output. Okay, so if we consider one more example, so the elements are 3, 5, 1. So this is the input root elements we have, and p and q are 5 and 4. So if we take for 5, the ancestor is 3, and for 4 the ancestor is 2 and 5. Here common is 5 itself is the common lowest common ancestor. Okay, so let's understand the solution, how we can solve it. So consider this example. So 3, 5, 1, 6, 2, 0, 8, 7, 4. Let's find out lowest common ancestor between 6 and 4. Okay, lowest common ancestor between 6, 4. Okay, so for 6, what are the ancestors here? So if you draw the path, right, how it looks like, how the path will come to 6 and 4. It will come like this, right? Correct. Here the common ancestor is 5 for both 6 and 4. For 6, what are the ancestors? 5 and 3. So for 6, ancestors are 5 and 3. And for 4, what are the ancestors? 2, 5, 3. Correct. So for 4, ancestors are 2, 5, 3. Okay. Here the common ancestors, that we have to return the lowest common ancestor, right? That is 5 between both. There is the lowest common ancestor. We have to return 5 is the output for this. Correct. So let's understand how we can solve it. Okay. So the first way to solve this up, this is there is a brute force approach. So for 6, let's draw the path for 6. Okay, for 6 the path is this one, right? 3 to 6. Correct. That is 3, 5, 6. Correct. And for 4, what is the path? How we can draw the path for 4 like this, right? Correct. That is 3, 5, 2, 4. Okay, so 3 and 3 matching. Correct. And 5 is matching, and 6, 2 are not matching. Correct. So whatever the last value which is matched, right, that we can return as a output. That is the lowest common ancestor. Okay, in this case that is 5. So this is the brute force approach. Okay, so the brute force approach will take time complexity as order of n. Correct. Again, we need to store the path right here. For this order of n, again we need to store the path, that is order of n, that is space complexity. Again, for this 4 also, again the time complexity is order of n, space complexity is order of n. Correct, to store the path. So ideally we are taking some extra space here. Okay, so how we can optimize it? Okay, let's understand the optimal approach. Okay, I don't want to use the extra space. Okay, let's understand the optimal solution now. Okay, so the optimal approach is, so we'll start use the DFS approach. Okay, DFS approach with recursive calls. Fine. So first from 3 we'll call the left node, that is 5. From 5 again we'll go to 6. So here we have to find out common ancestor between 6 and 4, right? Fine. So first we'll move to 6, from 3 to 5, 5 to 6. So wherever this node is matching with any of this element, right? 6, it's matching, right? We will return that element, that node. Okay. If we match is there between any either 6 or 4, we will return this. Fine. And from again, once left is done, we'll move to right. Correct. So right from 5 to 2, again from 2 to here 7. Correct. So 7 is matching any 6 or 4? No, it's not matching. So we will return null. Whenever it's not matching, we will return null. And from so left subtree is done, we'll move to right subtree. That is 2 to 4. So 4 is matching, right? We will return 4 here. Correct. Here null and 4 is there. So we will return here 4. Correct. So from here we are returning 6. From here we are returning 4. Correct. If both are matching, so this is our output, right? We have to return its root element. Okay, 5. So from here we have to return 5 if both are matching. Correct. From this left complete subtree is done. We are returning 5. Now move to right subtree, 3 to 1. So 1 to 0. It's not matching, right? So we return null here. Correct. So again move to right. Here we are returning null. So from here both are null. Obviously we have to return null. So if any one is not null, we have to return not null value. That is 5. 5 is our final output. Okay. So it will take just order of n is a time complexity and order of n space complexity. Okay. Let's write the code and submit it. So the first check is if root is null, okay, or if root is matching with any of the p value, or root is matching with q. Okay, we have to return the root to first check. Okay. Now keep recursively call the left and right subtrees. Okay. So tree node left. So I want to call the same function. Dot left. Let's pass same variables. Same way, call right also. Right subtree. So here right subtree. Once these are done, so if we see this example, right? If suppose left is null, we have to return right. Correct. If right is null, we have to return left. If both are not null, we are returning root. Okay, that's what our next check. If left is null, return right. Else if right is null, return left. Else means if both are not null. Okay, what we have to return the root itself. This condition, right? If both are not null, we are returning the root itself. Correct. That's it. Let's test this. So there is a compilation error. What is this? Sorry, double quotes. Let's submit. Yeah, so that answer is that's accepted. So this is the solution for finding lowest common ancestor. Okay. Thanks for watching this video.